Welcome to day 4 of our Pollinator Power Party. Today is lovely Lepidoptera Day. It is a big day for moths and butterflies. So if you missed the prior few days of the party, it's been a really great week this week, and you can re-watch any of the sessions Monday, Tuesday, or Wednesday on YouTube. For the goals of the party, we're still working towards meeting our goal to reach 2.5 million people during the party and during National Pollinator Week. We really need to reach that goal in order to continue the party next year. So just shout out to everybody. We're going to work as a big party team and make sure that we get this in the eyes and in the hands of everybody, all our friends, all our coworkers. If you work for a company, get your company to do a social media post on it. Okay, so for our winners yesterday, if you come, there's daily party winners. So yesterday, the announcement for the winners is Fiona Caldwell King and Tatiana Lerma. So congratulations to the party winners. You guys are going to get a really beautiful Wings of Life poster, which focuses actually on butterflies and moths. So we'll ship that out to you. Good job. And then for folks that join every day for the whole party, so just so you guys know, if you're trying to go for the grand prize, we have about 400 people that are coming every day and haven't missed a day. So good job, you guys. So if you're going to try for that, there's a few prizes. One of them is this book, Gardening for Butterflies. It will be a signed and autographed book by the experts at Xerces Society. Also, a signed book, Nature's Best Hope by Doug Tallamy is one of the grand prize. And just because we've had phenomenal engagement this year, there's actually another grand prize that wasn't previously announced. Copy of this book called Sustainable Electricity. This is actually my book. There's stories about what power companies are doing around sustainability and how they're helping to achieve sustainable electricity. So you get to have a signed copy from me of this book. So that's a good prize. So keep it going, come every day. And okay, so for today our content is super fun. Sometimes it's hard to control these Lepidoptera scientists, as you'll see. So we get into some great detailed presentations. And then I do a Q&A with all of the scientists. We have 3 today. Kevin Burles from Xerces Society, Junaid Khan from Pollinator Partnership, and Chip Taylor from University of Kansas, and also the founder of Monarch Watch. So 3 really phenomenal scientists that we're bringing straight to you, to your living room and your offices. So this is going to be a fun day. So engage in the chat. All 3 of them are in the chat, so you can ask them questions. And then also a special story today is Los Angeles Department of Water and Power. We have a project with them to restore pollinator habitat at the Hollywood Reservoir. And so the first story you're going to hear today is actually about this restoration and education project around the Hollywood sign at the Hollywood Reservoir. So packed day. We are going to run about 5 minutes over, but I think it's going to be worth it. So stay on with us for an extra 5 minutes today, and be sure to engage in the chat. You guys are blowing up the chat every day. Good job. All right, let's get this party started. See you on the other side.
Obscure pollinator is the soldier beetle, Chaliognathus pennsylvanicus. Long ago, almost 20 million years before there were bees to pollinate so many of the plants which rely on, there were beetles. Magnolias, for example, are an ancient plant lineage that relied on beetles for pollination in the absence of bees and wasps. Today, many beetle-pollinated plants, like magnolias, have large, showy, fragrant, and cup-like flowers with leathery petals, which are a direct result of the plant strengthening itself for visiting beetles. A common North American beetle is a group called soldier beetles, or leatherwings, a beneficial insect and important pollinator who not only finds a good snack in the nectar and pollen of flowers, but also in other insect eggs and larvae. Soldier beetles survive through the winter as larvae, and then in the spring, they become active in leaf litter and plant debris, sometimes for up to 3 years. Then, in late summer, the adult soldier beetles visit many flowers, such as Queen Anne's lace, milkweed, rattlesnake master, solidalgo, and other late summer flowering plants. So, next time you find yourself in the garden, keep your eyes out for these resilient, bright yellow creatures visiting your flowers.
At LADWP, we believe that pollinators are very important. And if you look at the things that we've emphasized, it's not just water and power, but it's also the creation of natural plants, the replacement of turf with native plant species and California-friendly gardens, all the way up to the Eastern Sierra up north, where we have major revegetation programs where we're bringing native vegetation back into the environment, both to offset the incidence of invasive weed species and also to bring the environment back to what it's been centuries ago. And it's so important to look at the lands that we own and to see how we can really promote the recreation of the natural environment, and the pollinators are such an important part of that.
So here we are at the Hollywood Reservoir. I am here with Maria at Los Angeles Department of Water and Power, and we are so excited at EPRI to be scoping out this project with LADWP. The opportunity here is just phenomenal to have the Hollywood sign. This is an iconic place in Los Angeles. It is a travel destination, and we're working on restoring and educating about some of the pollinator habitat here.
This renewed focus on the ecosystem, protecting pollinators, and addressing the critical biodiversity issues is really the next step of our focus.
My name is Helen Olivares. I am a waterworks engineer for the Los Angeles Department of Water and Power, and my team and I manage all of the water system facilities within the LA metro area, including Hollywood Reservoir.
Our group operates and maintains the Hollywood Reservoir property, which is about 400 acres. In this property, this includes the actual Hollywood Reservoir itself, and in addition to being really beautiful, it serves as an emergency water supply. Around the Hollywood Reservoir, there's a 3.5-mile walking path, and that's open to the public every day.
I was so pleased when I got here and could see all the native plants that were already here. So the project here is really about optimization and then creating that opportunity for education and outreach. Pollinators and ecosystems don't just have to be put within their special park reserve, right? You can have concrete, and you can have fences, and you can have urban habitat. And so the idea that there is basically a road here, a 3.5-mile road, at first I was like, oh my gosh, there's a road. And then I was like, this is amazing. Anybody in a wheelchair or a bicycle, or if you want to go running or hiking or anything, anybody can come here and use this road, right? As an example.
This pollinator initiative is fantastic. In the 1970s, when there was this incredible discovery about how systems thinking was very important, that we couldn't just be planning for anything from where we were putting housing or where we were doing roads, but that it had to be an integrated strategy where you were actually thinking about the forests and what the forests gave us, and the transportation systems and the water. And there was a consciousness, I would say, in the last 10, 15 years about bees. And then as we started getting deeper into the bees and wasps, the nursery started growing the plant material.
So since all this drought started, we've been refraining from using lawns. All our lawns, we stopped watering them, and slowly we've been converting every station to a more drought-tolerant landscape, using pollinators, agaves, anything with to minimize the overhead spraying.
Salvia apiana, or white sage. This plant is it's native locally. You'll find it more on drier slopes higher up, some of the high points at the facility. It has a very strong aromatic fragrance, and it's a great pollinator plant. It'll shoot flower spikes up sometimes 4 or 5 feet high, and you'll just hear them buzzing with all different species of honeybees and native local bees, sand bees, hoverflies, hummingbirds take a crack at it. We have our own in-house nursery, and we keep all of these there. We use these on projects. When we do pollinator gardens, sometimes we're doing plantings at distribution facilities and under transmission lines, and whenever possible, we use these native plants.
Can you talk a little bit about the diversity of your customers and who you have to actually serve within Los Angeles?
LA is a cultural melting pot with over 95 languages spoken in homes. LADWP has, made sure that all of our programs and incentives are true to equity metrics, right? Making sure that we take a look at things with a lens toward equity, diversity, and inclusion.
This topic of pollinators is fundamentally an equity issue, because we all depend on food and we all eat food. And if pollinators are in decline and are at risk themselves, then our safe and cost-effective and nutritious food supply is at risk. And who will receive the brunt of that first is the communities that have the least ability to handle it.
Absolutely. And again, at LADWP, we look at affordability as one of the key issues of our programs, right? And just making sure that, as we continue to invest in providing green energy and sustainable water to Los Angeles, that we make sure that our rates continue to be affordable. Because at the end of the day, it is the underserved and the disadvantaged communities that already bear the brunt of climate change in terms of pollution and food insecurity, right? That have to also add to their bills, their electric utility bill. And so we make sure that we are part of the solution at LADWP.
Everyone should be a 10-minute walk to a park, but we do not have that. And that park and that green space are homes for our pollinators. And that's why the board places a huge priority on our pollinator initiative, because our transmission lines, our projects span 7 states. That's a huge asset for us. We have all of those available spaces that we can create and design from scratch so that those pollinators will have a home and will be as friendly as a habitat to our residents, 4 million residents in the city of Los Angeles. And mind you, the loss of habitat for our pollinators affect everything that we do. From our food system to our water system, they are impacting the health of our communities.
This project at the Hollywood Reservoir to provide an educational opportunity for the general public that's there to go for a hike or exercise. But while they're there, we can inoculate them with science about pollinators.
This Power in Pollinators program really allows us to take a pause and learn, not just from the scientific experts, the technical experts, but also from our colleagues from all over North America with other electric utilities working together to protect pollinators.
I learned how there's over 5,000 species of bees in the USA, and I thought there was only 3. And I learned how a lot of them are very helpful, how when they carry the pollen, it can grow fruits and vegetables that we eat.
Because they like help us with like having fruit and vegetables.
I thought it was cool because every like bee is not the same and they have like a different like place to go home.
I like a bumblebee because it's furry, fluffy.
I also like a bumblebee because they're really fluffy and yeah.
I would like try to not bother them so they wouldn't sting, because I know like that like when they sting you, like it rips their organs out.
Salam, bonjour, Anin, EPRI Power Party 2022. My name is Janae Shahzad Khan. I work as an ecologist with Pollinator Partnership Canada, and I'm speaking to you today from Nogo-Jiwanong, Peterborough, on Treaty 20 territory, representing Pollinator Partnership Canada in Takaranto on Treaty 13 territory. And I would like to acknowledge and thank all of the thousands of nations and peoples who have helped cultivate and foster the biodiversity that we are here talking to you about today. Without the Anishinaabe, the Haudenosaunee, the Chippewa, the Huron, the Wendat, the Métis, and many other peoples, we would not have the underlying species of plants and trees that support all of the biodiversity that we continue to see here today. I'm here today to talk to you about the group of moths and butterflies known as Lepidoptera. Globally, there are about 180,000 species of Lepidoptera that have been described, but considering we discover many more each year, it's estimated that the global species are closer to between 300 and 500,000. A majority of these species are moths, and by some estimates, there are about 10 times as many moths in the world as there are butterflies. There are about 5,300 species of Lepidoptera known in Canada, of which just about 300 to 302 are butterflies. And the rest of the 5,000, and many more that we likely do not know of, are moths. Most moth groups are too poorly known to even be assigned any sort of general status ranking or do a species list. We know the largest of the moth groups the best, also known as the macro moths. So this includes giant silk moths, sphinx moths, tiger moths, underwing moths, and so on. In the family tree of butterflies, many moth species are more closely related to butterflies than to other moths. So this is the family tree for the entirety of the known Lepidoptera in the world. And as you can see, it's quite a complex grouping. Within this group, the Pollinator is where the entirety of the butterflies fit. All the rest of these groups are moths. So in an effort to shed more light on the complexity of this family, it can be helpful to think of butterflies as day-flying specialist moths, rather than like a hard-lined, distinguishable group from moths in general, as there are many other day-flying moth species as well. Butterfly specialization does mean that identifying this group from other Lepidoptera has some rules. So in your day-to-day, how does one identify a butterfly amidst the varying colors, shapes, and sizes? Some identification guides will speak to how the insect holds its wings when it's resting, though that is better used when distinguishing species from each other rather than overall groups. In North America, the easiest way to differentiate a butterfly from a moth is by looking at their antennae. Butterflies have clubbed antennae in North America, and moths have feathered or comb-like antennae. And this distinction is set out on the EPRI Lepidoptera fact list for this year as well, which is a great resource to be able to just quickly refer to in case you don't want to listen to me ramble on about Lepidoptera again. Of all the butterflies in North America, the monarch butterfly has garnered by far the most attention, and there are some very key reasons for that. This species is unique for its long-distance migration. Over 50 million butterflies travel over 5,000 kilometers over multiple generations from southern Canada to Mexico. It also captures the imagination to see all these millions of butterflies gather in an area where occupied roosts have shrunk from 20 hectares to just 2 in the past 20 years. This is the area of the Oyamel fir forests of Mexico. So this species truly connects North America, and there's a lot of political and cultural poetry in that. The challenges it faces is also emblematic of the challenges of other Lepidoptera cousins, and indeed entire ecosystems as a whole. We'll be hearing more about their populations, about the populations of monarch butterflies from Dr. Taylor later on. And because we know all of this about monarchs, I want to tell you crucially that you cannot apply what we have learned about monarchs to all other species of Lepidoptera. There's a reason we're fascinated with monarch butterflies. Their habit of long distance migration at this scale is very unique. Most of our other native butterflies do not migrate and either overwinter as chrysali or chrysalises, and in some cases, like this mourning cloak, as adults. This means that their life cycles become visible much earlier in the season than monarchs. Many species will become active well before any forb flowers are in bloom. Kevin Burles will be speaking more to the habitat needs of butterflies and moths and how you can help them complete their life cycles. Now, finally, as far as pollination services go, butterflies aren't really known to be the most effective pollinators. And this is due to many interconnected factors. For example, butterflies do not actively collect pollen like bees do, so they do not have any specialized structures to support pollen collection. In most cases, the pollen is carried on a butterfly's proboscis as it tries to gain access to the nectar within a flower. The life cycle of butterflies is also more dependent on the presence of the proper food plant for the caterpillar stage than it is on nectar availability for adults. So in the absence of floral resources in the early spring and late fall, butterflies feed on the sweet sap of trees and shrubs, mineral-rich edges of tide pools, and on the droppings and urine of animals. Butterflies also don't really have the body shape or positioning on a flower to be able to collect pollen. Bees really get in there. You know, when a bee is on a flower, its entire body is in contact with the pollen sources. With a butterfly, they tend to hold themselves a little bit further from the bloom itself, and so there's not that much contact with pollen as well. This does not mean that there aren't many specialized relationships between plants and Lepidoptera, though. Caterpillars of many species specialize in feeding of the foliage of certain native plants, and without these plants, the populations of these Lepidoptera can plummet. In Ontario, for example, the Carner blue butterfly is extirpated, means locally there's no more Carner blue butterflies that exist. And this is primarily due to the loss of its host plant, the wild lupine. Where wild lupine is still found further south of us, Carner blue butterflies are still around as well. You may already know for the need of milkweed plants for the monarch caterpillars, and there are many more species that we know this information for. Multiply these relationships out by a factor of 10 or even 100, and that is the number of Lepidoptera plant relationships that we know nothing about. So creating habitat with a diversity of native plant species will help us support these incredible species so we can continue to learn from their amazing ways. Thank you for your time, Power Party. I am now going to pass it back.
Hello, welcome. Thank you all for being a part of our lovely Lepidoptera session here today. My name is Kevin Burles. I am a conservation biologist for the Xerces Society for Invertebrate Conservation. I am excited to be here today. Janae gave such a wonderful introduction to the world of moths and butterflies, and I'm going to piggyback off that a little bit and talk more about the habitat needs of moths and butterflies, how some of those habitat needs and those specialized relationships can sometimes cause them to be threatened by human activities, and some of the things that we can do to lessen those threats and also to just enhance pollinator habitat where you all work and live. So let's get started. As Junaid mentioned, the most specialized relationship that most moths and butterflies have is between the caterpillar life stage of that animal and their host plants, or the plants they feed on. And so when we talk about habitat needs for moths and butterflies, we're first and foremost going to be talking about plants. And Lepidoptera are one of many very important groups of insects that feed on plants. And also, as Junaid mentioned, that is their most important ecological role, really, is as plant herbivores, not typically as pollinators of plants, but as herbivores of the plants that those caterpillars feed on. But caterpillars can't just eat any plants, they need the right plants. Most Lepidoptera can only eat a few types of plants. That is, each species has its own types of plants that it feeds on. Butterflies are generally a lot pickier than moths are, but here is an example on the left of a moth that is fairly picky. That is an animal that if you are a gardener, you might be familiar with. It is the tomato hornworm. And the tomato hornworm is called that because it feeds on tomatoes. You can see here, just so that it's clear, these are its 3 real, true sets of legs, followed by the pro legs in the back, and it's trying to hide upside down under a tomato stem here that it has eaten the leaves off of. And they need good plants to feed on as well. Sometimes plants can be sickly, they can be diseased, or they can be being predated on by other animals. And adult moths and butterflies will learn the plant quality when they lay eggs on it by tasting the plant with chemical receptors that are located on their feet. So this relationship between the butterfly and the plant and the caterpillar and the plant are very, very intimate and specialized. On top of that, most plants are full of toxic chemicals specifically made inside the plant to keep them from being eaten by other animals. And so this set of chemistry and the relationship between the plant chemistry and the animal is also a very specialized relationship. And it makes it very important when we start to talk about what specific plants different moths and butterflies need as habitat. As an example, I might start with something familiar like the monarch butterfly. Many of you have probably heard of the monarch butterfly before. Many of you probably know that the monarch butterfly eats milkweed as a caterpillar. And so I've got shown here the life cycle of the monarch butterfly. You can see the caterpillar, top center stage, eating its milkweed plants. You can see the chrysalis, which is not hanging as it usually does. It's laying on a table here. And you can see the brightly colored adults, which are slightly different between males and females. And as I mentioned, the monarch caterpillar eats milkweed, and milkweeds are a group of plants that are all in the genus Asclepias. As the monarch caterpillar is eating the milkweed has in it certain chemicals that are meant to keep it from being eaten by most other types of insects and most other types of caterpillars. One of these chemicals is shown here. It's called oleandrin. It's a type of chemical called a cardinaloid. And in vertebrates like us, if you ate a lot of milkweed, it would actually make your heart speed up a little bit. But to some other vertebrates like lizards or birds, and to many classes of invertebrates, it's just fairly toxic and can make them very sick. And it actually protects the caterpillar from being eaten because the caterpillar doesn't digest these chemicals, it just holds on to these chemicals in its body and protects them. And it actually protects the adult as well because the adult has these chemicals in their bodies as well. And it can make them slightly toxic to certain types of predators. But the other result of this specialized relationship is that it means that monarch caterpillars can only eat milkweeds. And so here I've shown you a selection of milkweeds. There are actually several dozen species of milkweeds in North America. They're all in the same genus Asclepias, and they all have those cardinaloids in them. So when monarch butterflies make their migration from central Mexico or from the coast of California in the springtime and into the summer, and they're looking for places to lay their eggs, they have to be able to find milkweed plants. And so, as I mentioned, each species of moth and butterfly has its own plants that it needs to find to lay its eggs on. And just as another example here, this is a broadly distributed butterfly across the western United States called the West Coast lady. We have found it's been in steep decline, and we're focusing on it as a target of some of our conservation efforts in the western United States. But you can see here that it lays on plants in 2 families, the mallow family and the nettle family. And so there are a few examples here of some very common mallows that you might see in your yard or on a hike in your local parks or natural spaces. And then also a slightly less charismatic plant on the right there is stinging nettle, which can protect the caterpillar for the same reason that it protects the plants. Most things don't want to reach very closely into a patch of stinging nettle. As adults, the habitat needs of moths and butterflies are very different than those of the caterpillars. First and foremost, they need to be able to find other adults of the same species to be able to mate and lay eggs and reproduce. But then the second thing that they need are plants that have flowers on them, and specifically flowers that have nectar in them. It's important to note that plants pollinated by wind don't have nectar in them. Two important examples would be corn and wheat. And some plants that have been bred for sale to have long bloom periods or exceptionally vibrant colors or things that sometimes are called double blooms. Many of these plants, because of their selective breeding, no longer have nectar in them. And that's one of the reasons why the Xerces Society and most other conservation organizations focus on native plants in pollinator habitat restoration. Most adult butterflies will feed on many kinds of flowers. I have shown on the left here the smallest and largest butterflies in my region, Northwest Nevada, the pygmy blue and the two-tailed swallowtail. Both of these species of butterflies can be found feeding on a variety of plants as long as they're the general right shape and size and have nectar in them and are available wherever they're found. I do think it's important to note that many types of moths do not feed as adults. Their lifestyle is such that they build up very, very large reserves in energy as caterpillars, and so they no longer need to find flowers as adults. They're able to live out their entire life cycle without feeding on flowers. And while we're talking about moths, I think that's a nice segue into one of the other more important habitat needs of flying insects, and that's dark skies. Moths are one of the more notable examples for which light pollution can be a threat, but as it turns out, there are many other groups of insects that benefit from dark skies. Many types of insects are drawn towards artificial light sources, not just those that are active at night. It's not just moths. You'll see many types of insects like ladybugs shown here, some bees, and other groups of insects like praying mantids are also drawn to artificial light sources. And nightlight has also been shown in some very recent studies to affect the migratory abilities of day-flying insects. And both of these things waste energy that's very valuable for insects that they need during their flight periods. On top of that, predators are often drawn towards artificial light sources because they know those are areas where there'll be high concentrations of prey items. And groups of insects like fireflies that use light as a means of communication are also very, very vulnerable to the effects of artificial light pollution. When it comes to discussing the other threats that butterflies and moths face throughout their life cycles, it can be slightly depressing in today's world because there are many things that we now know negatively influence butterfly and moth populations, among other types of insects. And oftentimes there are multiple threats that can be found in the same area, and some of these threats can be very widespread in their effects on insect populations. And there are some recent studies that summarize these threats here, and I've drawn I pulled a photo from one of them here. But I want to highlight three general aspects of insect threats. The first is habitat loss. Habitat loss has long been considered the #1 cause of local biodiversity loss in any given area, and that is still generally true. For insects, though, pesticide exposure appears to be a close second place in their effects on modern insect declines, and that's something that we're only still continuing to realize with more current research being done. And lastly, climate change, especially drought and warming at certain times of year, have been shown to have a fairly large influence on butterfly declines. The good news here is that there are things that everybody can do to help benefit moth and butterfly populations, no matter where you live or what scale you can work at. And as I mentioned, habitat loss is often considered the #1 cause of declines for many different types of species. So the #1 thing that you can do is replace some of that habitat. And this is, at the bottom here, I have a study that was co-authored by our executive director, Scott Hoffman-Black. And in that paper, they point out that the #1 thing that you can do to benefit butterfly and moth populations is to plant caterpillar food plants and adult nectar plants, especially when they replace lawns or other monocultures. Picking pollinator plants can be overwhelming because of the pure number of plants that there are in the world, and because of the need to know if it's a good pollinator plant and if it's appropriate for the area in which you live. And so I just want to point you to some of the resources that the Xerces Society has available that can give you more information on the life cycles of pollinators and their habitat needs, more specific information on butterflies and moths, resources to help you pick plants that are free from pesticides that could potentially harm caterpillars, and more resources specifically on nectar plants. And the book on the right there is made specifically for the monarch, but as I've mentioned, because of the general relationship between butterfly adults and nectar plants, you can use that as a resource to provide nectar plants for many different types of pollinators. The second thing that we can all do to help protect moth and butterfly populations is to reduce the level of exposure of these populations to pesticides in our local area. And there is a pressing need to do this. Studies have come out recently and continue to come out that show that pesticides are very common even in seemingly natural environments far away from agriculture, urban areas, or other direct pesticide sources. Some pesticides, especially things we call systemic pesticides, can be long-lasting in plants and in the soil, and are often present in nectar, pollen, and leaf tissues, which then exposes them to native caterpillars as well as adult pollinators and other flower-visiting insects. And the thing that you should know that's important is that there are many ways to reduce the amounts of pesticides that you need throughout the season. And some of them are very, very simple. And I have one example on the right, which is just cleaning bird baths. Bird baths are a wonderful feature to add to your backyard, and they are also a magnet for mosquito populations. By changing your bird bath regularly, you can reduce the level of exposure that you have to mosquito pest populations and the need for pesticides to be applied in your local environment. There are many other ways to help protect your local pollinator populations from pesticides and to help reduce the need that you have for pesticides in your environment. As I mentioned when we were talking about caterpillar food plants, the Xerces Society has resources to help you pick plants from locations that don't use pesticides that are known to harm native caterpillars and pollinators. As you are managing pests in your yard or garden, the Xerces Society also has resources to help you avoid the need for systemic pesticides that can be very damaging to beneficial insects. We also have a program that's called the Be Better Certified label, which is dedicated to helping shoppers and producers advertise that they are using pollinator safe practices. And then you can also be an advocate to your local governments when it comes to their need to apply pesticides in public spaces. And we have resources available to help managers of local parks and open areas reduce their pesticide use as well. And with that, I will stop there. I'd like to say thank you very much for listening to me today. I hope you all feel inspired to go out and find and buy a caterpillar food plant and create some pollinator habitat today. And if you would like to support the invertebrate conservation work that we do at the Xerces Society, we are a member-supported nonprofit organization, and I would encourage you to visit our website at xerces.org and become a member today to support the work that we do across the United States. Thank you again, and have a wonderful day.
All right. Hi, everybody. I'm Chip Taylor. I'm director of Monarch Watch at the University of Kansas. Monarch Watch has been around a long time. We're celebrating our 30th year anniversary this year. And I hope some of you will come and join us here in Lawrence, Kansas when we have that celebration in September. Well, what I want to introduce you to is what's going on with monarchs this year. And I want to tell you a little bit about the dynamics of the population and review a little overall biology and annual cycle with you. So the thing that we need to cover is how the monarchs move for the entire year. And as you probably know, they overwinter in Mexico, and we'll go into that in a little detail in the future here. But they come out of the overwintering sites in Mexico in March, and they move up into that kind of light green area there. And that's where the overwintering monarchs come into the United States and where they begin to reproduce. then their offspring go up into that yellow area that you see above, all the way up into Canada, into, say, as far north as Winnipeg. And then they go through two more generations generally, and then the migration south starts again in the beginning of August up in Winnipeg. But that's the eastern population. The western population is a population that overwinters on the California coast. You see that little blue strip over there along the California coast. That's where most of the western monarchs overwinter. That's a smaller population. It's a much more enigmatic population because it occupies a huge area, but where human densities are pretty low, and we have a lot less information about how that population functions. Now, the next slide will take you to Mexico, where they are overwintering, and they overwinter in these absolutely magnificent clusters. Trees are just covered with these butterflies, and the area of trees that are occupied by butterflies is measured each year, and that measurement constitutes the size of the overwintering population. And this is pretty unique. You know, for most organisms, we don't have an estimate of the number of individual butterflies or individuals of any species, really. I mean, we have a lot of guesswork, and in case of monarchs, the only guesswork really amounts to kind of understanding the total area that the butterflies occupy in the wintertime. And they overwinter in these oyamel fir trees in these massive numbers. But one of the things that happens in that overwintering stage is that those clusters break from time to time in what we call cascades. And can you count? Are you really good at counting? Can you count all of those butterflies really fast? I can count 4 people in the background and I can barely see them. Yeah, 1, 2, 3, 4. And I was there taking this picture and I was just amazed. I mean, if you opened your mouth, you might catch a butterfly. That was that many butterflies. And they're coming off a huge set of clusters in these trees. And why they're doing this isn't clear, but it seems to be that they'll do this whenever there is a slight disturbance, perhaps a passing cloud or perhaps a bit of a wind or something of that sort. Well, this sort of movement is pretty spectacular, but it's also accompanied by another type of movement. And that is when we get late in the winter, we see the butterflies begin to stream down from these overwintering clusters and they go off to seek water. And I happen to be standing in one of those rivers of butterflies, those streams of butterflies in Macheros in the 1st of March in 2007. And it was just an awe-inspiring event. I mean, I just couldn't stop taking pictures. This is one of my favorite pictures of that event. It's hard to get all these butterflies in focus. And this was the best one I got. But it's really unbelievable to see literally tens of thousands of butterflies streaming past you in what appears to be a river of butterflies. And they're going down to seek water. They need the water to metabolize their fats, to produce the sugars they need to fly back to the United States, starting usually around the 1st of March. And then we have this total that we deal with when we're talking about Mexico. And it's a pretty good estimate of what's going on because we can kind of predict the estimate. We have a tagging program at Monarch Watch where we tag an awful lot of monarchs each fall. And the number of monarchs that are tagged in the fall pretty much correlate with these overwintering estimates. So there is a relationship here. It's not just hocus pocus that, we have good years and bad years with monarchs. And we can see that in the monarch tagging, and we can see that at the overwintering numbers. And we can actually predict the overwintering numbers to some degree. We're not always accurate. In fact, we're usually underestimating the numbers. But if we had all of the tagging data available at the time we were making the estimates, we'd probably be much, much closer. All right, the next thing I want to bring to your attention is the fact that what's happening across the United States is being modified by temperature changes that are related to long-term climate change. When I put this together, this is a figure showing the average amount of change that occurs per decade from 1975 through 2020. And you can see that if we go over to the West Coast, that's heating up really, really fast. And then we can see that all along the coastlines, whether we go from California, Oregon, California, swing down to Texas, go through the southern Gulf states and up into the New England states, that all of those rim states, those areas around the US that are connected to the oceans, those are heating up faster than the Midwest is. If you look at the Dakotas and Iowa, you can see that that area is changing much more slowly in terms of summer temperatures than of the coastal areas. And that's because of two things. One, all of the coastal areas are adjacent to oceans that are, or bodies of water that are heating up really fast. Because the excess energy that's being stored because of the amount of CO2 in the atmosphere is absorbed in the ocean, about 90% of that energy is absorbed in the ocean. The oceans are heating up, and that's modifying all our coastal temperatures. But at the same time, the resistance to that is what we see in the central part of the country, where the jet stream sits over the central part of the US and southern Canada in the summer months, and it keeps it a little bit steadier. And so it's not we're not experiencing the amount of climate change in the Midwest that they're experiencing on the coast. That all becomes important because we're going to be talking about the Western population, which is really in jeopardy because of those changes. Here's another graphic that shows you the average temperature in California from 1895 through the present time. And you can see that over that period, the temperature in California has increased by 3 degrees Fahrenheit. And most of that temperature change has occurred since 1960. So this rapid temperature change in California has had a major effect on monarch populations, agriculture, and a whole lot of other things that are going on in California. And as you're probably aware, there's an extreme drought there going on there at this time. And that also is having a big impact on things like monarch butterflies and a lot of the pollinators out there. So people that I correspond with in the West are telling me that things are really changing rapidly. And it's partly due to two things. One is the increasing temperatures, but when you get increasing temperatures, you usually get less moisture. And so the droughts that are going along with increasing temperatures are having a very strong negative effect on a lot of different things out there, including monarch butterflies. Next, we should take a look at what's happening this year. And what's happening this year in the East, the Eastern population, which we're focused on most of the time with Monarch Watch, is very interesting. It's very unique. These are the first sightings recorded by Journey North through the 23rd of May this year. And you can see that there's a tremendous number of first sightings. This is unusual. I debated about how to show this to you because this is pretty unique to see this many kind of red dots up in the upper Midwest north of 40 North. So when we look at the monarch reproduction in the East, it's clear that most of the monarchs that come to the overwintering sites in Mexico originate north of 40 North, which is a line that kind of runs north of Kansas City, from St. Joseph all the way to the East Coast. And you can just barely see that that latitude line there up around Kansas City, just north of Kansas City, and just runs just south of Philadelphia. So those red dots up there all represent monarchs that have been seen this year before the 23rd. And that is that whenever we see something like that, it signals that this population is going to grow really well this year. And look at all the butterflies that are along the East Coast, going right up even north of Boston. And then the last few days, we've had a lot of butterflies for this time of year, and a lot of butterflies showing up even as far north as New Brunswick, which is in the coastal provinces of Canada. So this is pretty unique, and it's unique because the last time we saw this was in 2018, and in 2018, we had a very good population of 6 hectares, the largest population we've seen since 2006. So things are looking up this year. This looks like the potential this year is that we could have a population that's about 6 hectares again, or maybe even more than that, because this is a better recolonization this year than it was last year. So things are positive here, and we're pleased to see this sort of event developing. We're not out of the woods yet. We really have to wait and see all of the recolonization that occurs right up through the 14th of June. But once we get past that point, we'll be able to see how the population is going to continue to develop. But right now, things are good. I'm happy. I'm really pleased that we're going to see some more monarchs here, and I'm not going to worry about the population collapsing, at least not this year. All right, well, we got to keep them flying, and to keep them flying, we're going to have to create a lot of habitat out there. As you may know, we have a Monarch Waste Station program, which has got over 38,000 registered sites around the country, and in 8 different countries, foreign countries as well. So the idea of creating habitats for monarch butterflies or any other species that is of interest to you is real. It's measured and advocated by this brand that we have, which we call the Monarch Waste Station program. And Monarch waste stations can be any size. They can be small. They just have to contain the host plants for monarchs, which are milkweeds, and they have to contain some nectar sources that will feed the adults. Anyway, I hope you will all get involved in monarch conservation. It's a very important thing to do. This is an iconic species. We can't lose it. We don't want to lose those spectacular assortments of phenomena that we see with streaming and cascading, and the wonder that everybody has when they walk into that forest and see those masses of clustered butterflies. Well, with that, I'm going to end this little conversation, and hope that you got some idea of the extent and the magnificence of this monarch migration and the value that it has in keeping us connected with the nature that supports us. Well, thank you very much for listening.
Thank you for sharing all of your expert talks. We just saw all your talks, Junaid. We saw you, and then Kevin, and then Chip took us into a deep dive about monarchs. So a question is, what are Lepidoptera really important for pollinators and for ourselves as humans and for the ecosystem? I mean, is this really something that makes sense for us to take time to talk about? Junaid, what do you think?
Absolutely. We have a lot of storytelling around butterflies, and a lot of fascination with their colors and the art that they inspire, and the poetry they inspire in human culture. But their ecological role is far greater than I think we understand and definitely give them credit for. And when we're saying Lepidoptera, we're talking about, this ginormous family that includes moths and butterflies, moths by a significantly higher proportion than butterflies. And their life cycles are very much tied to our human life cycles. So every single butterfly that you're going to see this year exists in the ecosystem already in some form. And they're either going to make their way migrating over here, which is, at least in Canada, very few species. Most of our butterflies are here right now, and they're going to be here their whole lives. They're just going to stick around in their native neighborhoods. So we're a lot closer to them than we think as well. So yeah, I think this conversation is incredibly important, and everybody has a role that they can play in it too.
So Kevin, are butterflies and moths actually, are they just honorary pollinators where they're really not getting the job done, but they look pretty and we kind of like them, so we kind of keep saying they're pollinators, or are they really pollinators?
In some cases, that's true. In some cases, they are what I call incidental pollinators, and I feel like that's a decent term. They are fairly hairy, some of them, and so they can get pollen on them. But one of the things that bees and honeybees especially have that makes them good pollinators is what people call floral fidelity. which is the desire to want to visit the same type of flower over and over again. Bees, especially honeybees, have that trait. Butterflies typically don't so much. So because they're not visiting the same type of flower all the time, they're much less likely to be the main pollinator of any given plant. But that said, there are radical exceptions to that. So there's one famous species of orchid that's known as Darwin's orchid, and the plant was discovered long before its pollinator. And the plant is a showy orchid, and the nectar source that an insect would be going for is some 14 inches or so below the entrance to the flower. And so by inference, you assume there is a pollinator with a 14-inch tongue that can reach down to the bottom. And that moth was discovered decades after the orchid. So that's one example. And then another example that's closer to my area would be yucca moths, which have to pollinate the yuccas to create the developing seeds that the moth caterpillars are going to feed on for their development. And so some of those seeds are eaten through the development and some are not and go towards the plant's reproduction. So there's definite examples of where they are the main pollinators in some ecosystems and some what we might call a mutualistic interaction.
So that tongue that goes down, that's called the proboscis.
Yeah, that's right.
Okay, so the proboscis is basically like a straw that sucks up nectar. And so different flowers then, so different moths or butterflies have different lengths of proboscis that would be have high fidelity to particular species of flowers. Is that right?
Yeah, that's definitely true. And I think, not positive, I think the moth pollinator of Darwin's orchid is a species of sphinx moth. If I'm wrong about that, it is still true that sphinx moths in general have some of the longer proboscises of Lepidoptera and are often the ones that we associate with some of those longer, more extreme shaped flowers. Even honeysuckle is an example that's often attracted to clearwing moths and other sphinx moths. So yeah.
So I'm really interested in this moths, they're not very pretty.
Oh, that's only your opinion.
That's because you're not seeing them and paying attention. Okay, you see them in a bit of light. Some of these moths.
Or in the eastern U.S., the Luna moth is gorgeous by anybody's standards.
Come on,
that's
there's a green moth, semicircular, flying in the middle of the night. It's gorgeous.
Crossing tails, yeah.
Yeah.
I have a personal experience with moth pollination.
Uh-huh.
I was teaching a course up in Itasca in Minnesota, and we were doing field problems. And we had a plant that was very common in the fields, and we couldn't figure out what was pollinating it. And it was clearly setting seed, but we never saw any pollinators on the plant. So we dusted the plants with a little bit of reflectant dust that would be seen with a UV lamp. And then we went out at night, and the dust was spread all over the place. It went from flower to flower to flower. And the culprit was a moth. It was a moth-pollinated plant. And we didn't know that, and there was no literature on it. And yet, here it was, evidence. We could see the tracks that the moth was doing the job pollinating that plant. It was kind of fun.
That's incredible.
Yeah, that's beautiful natural history. Sure.
Yeah.
So is it possible at this point that we don't understand everything about moths?
Oh, you betcha.
Possible. It is definite. We understand like a tiny bit about butterflies, and butterflies are like a small proportion of this giant family that include many more moths than butterflies. So yeah, we definitely do not know enough about moths.
So moths. So here's something that I learned about moths from Kevin's talk. Was moths do not feed as adults. Is that true?
Oh, wait a minute. There's some moths that feed as adults.
Some moths don't feed as adults. Right.
Yeah,
So a really good example is the Cecropia moth, which is like the largest moth. I think largest moth in North America, right? Cecropia.
I think so. I think
I
that's
believe
right.
so.
Yeah, I think
So
that's right.
that moth goes through like 5 life stages to get to this giant adult that has no mouth feeding parts. It is literally just a reproduction vessel. And so that is one example of quite a few related moths as well who don't feed as adults.
Yeah, that's typical of the whole family of Saturnine moths. So none of them feed as adults. So, but on the other hand, your sphinges, which we were talking about earlier with your long proboscis, they're actively feeding. Some of them are even migratory. I mean, you got the white line sphinx that comes up from southwest, migrates all the way across the country. It's a vigorous pollinator of plants at the end of the day. It's very crepuscular, very active, and it looks like a hummingbird. And a lot of people might, confuse it with a hummingbird.
So how long do these moths that do not feed as an adult, so they just purely, their entire mission in that adult form is to reproduce?
Yeah, hey, there we go. We get into reproduction now. All right. Yeah, their task is to find a mate, to consummate the mating, and to lay a lot of eggs in the right place, and start another generation.
How long do they
From
live?
Maybe a few days to a week, or depending on the gender too. The males will not live as long as the females usually in those instances. I like to point out, just because my background is mostly evolutionary biology, that one of the main hypotheses for the development of complete metamorphosis is the division of function between the stages, where the caterpillar is supposed to eat and grow, and the adult is supposed to mate and reproduce and disperse. And so that is like the clearest example of that division of function is in those moths, right? Because they don't need to eat. They have the energy that they have. They have one goal in particular, and they don't have to divide their time looking for adult resources at all. So kind of a fascinating.
Cool.
But make life a lot easier if you just had to do one thing at a time. But that's a pretty rapid dating cycle, 5 days.
Yeah. Well, typically the females, so folks may or may not know that a lot of communication between insects is done by small volatile compounds that we call pheromones, and females release very specific pheromones as soon as they emerge. Especially moths is very typical that they're going to release these huge amounts of pheromones. Male moths have huge feathery antennae to pick up those pheromones, and the females will often mate with a male before they fly off anywhere. So it is in fact the very first thing they do is ensure that they have eggs to go and lay around on plants.
Right. And the interesting counterpoint to that is that many of the butterflies, it's the males that have the pheromones.
Yes, that's right. Yeah, thank you.
And that's, how did that change take place? And, in one case, you're trying to communicate at night. In the other case, you're trying to communicate in the daytime, for the most part. I mean, there's only one group of butterflies that flies at night. So,
there's some more evidence of, I feel like, stronger sexual selection.
All right. I don't know why every time we get the Lepidoptera people on, we always have to curtail that at the end every time we get the butterfly and moth biologists. So that happened again here this year. We had that happen last year too. Okay, I think one thing that we can kind of take away from that is that we're still learning, right? I saw some things in the chat. Hey, I read this one paper or this one study or whatever. And it takes a lot of papers and a lot of studies and a lot of research. And even with that, we're still learning. But one thing consistent that we hear across the board, you plant native plants, you reduce unnecessary use of pesticides and herbicides. Kevin brought up the light pollution thing. And if you go a little deeper, you can look at replacing your monoculture with heterogeneous landscape. So meaning go from a lawn to something that has a diversity of plants and flowers and vegetation in there. Those are the key tips if you want to kind of help with pollinators. Okay, so if you want to hear more, learn more, don't forget we have the lovely Lepidoptera fact sheet that you can see. About 1,000 or 1,500 people of you have received our welcome package, and you would have already gotten your hard copy. Others that registered, those are on the way. We got another 500 mailing out today, and then we're going to keep doing that. You might get yours next week if you registered late, or this week. Tomorrow's Mythbusters. Come back here tomorrow. Tomorrow is only 8 minutes of video. The rest of it is all live. And we've got some scientists on there. I don't know what's going to happen tomorrow. You guys email your questions to us, pollinators@epri.com. You can do posts on the hashtag #PowerInPollinators. So come back tomorrow. We'll see how things go. Okay, that's a wrap. We'll see you tomorrow. Thanks so much for coming to the party.